Hi guys, welcome back to my channel. So in this video I'm going to explain the unit which is Raman effect. So this is the unit 1. So in this unit there are 5 paras. So I'm going to explain each and every para very easy and understanding manner. Let's start with the first para, which is this A para. So now let's see. So in the year 1930, the most unexpected thing happened in the world of science. Let's see what happened in 1930. So, a young Indian researcher, who is C.V. Raman, the full form of the C.V. is nothing but the Chandrasekhar Venkat Raman. So, his full name is Chandrasekhar Venkat Raman. So, in short, we'll call as C.V. Raman. Won the Nobel Prize for his physics for his groundbreaking discovery of the phenomena called as Raman effect. Now, let's understand what is Raman effect and how he worked on this Raman effect and how he won the Nobel Prize and each and everything clearly. Hearing from Tiruchirappalli in Tamil Nadu, Raman completed his early education in Presidency College, Chennai. So, the Raman was born in November 7th, 1888 in Tamil Nadu. So, which you already saw that like in 1930, he won the Nobel Prize for his invention of the Raman effect. Okay. Such was his interest in physics, and his father has been a physics teacher, and his father name is Chandrasekhar Ramanath Layer. So we can say that his inspiration is his own father because his father is a physics teacher. So his interest came from his father itself. That dispute clearing the civil service competitive exam and becoming the deputy accountant general in Kolkata. So who is the deputy accountant general? You all know is like he is some senior officer who will be managing the government accounts in it may be in the state wise or religious level. Okay, he's like a government officer. So he still found the time to pursue the scientific research at the Indian Association for the Cultivation of Science. So similarly, he has some time, like he kept some time for his research work also. In 1917, he finally gave up his administrative position to become the professional professor of physics at Calcutta University. సో మీరు ఈ ఫస్ట్ ప్యారా చూసారు కదా. సో దీంట్లో ఏం ఇన్ఫర్మేషన్ ఉంది? సో రామన్ ఎఫెక్ట్ అనేది ఎలా వచ్చింది? సో 1930లో సివి రామన్కి నోబెల్ ప్రైజ్ అనేది వచ్చింది బై ఇన్వెంటింగ్ దిస్ రామన్ ఎఫెక్ట్. ఓకే, హీ యూజువలీ విల్ బి స్టేయింగ్ ఇన్ ద తమిళనాడు అండ్ తన ఎడ్యుకేషన్ అంతా తమిళనాడులో అయ్యింది. సో తనకి ఈ ఫిజిక్స్ లైక్ ఈ రామన్ ఎఫెక్ట్ ఇన్వెంట్ చేయడానికి కానీ లేదా ఈ ఫిజిక్స్ మీద ఇంట్రెస్ట్ అనేది ఎలా వచ్చిందంటే బై హిస్ ఫాదర్, బికాస్ హిస్ ఫాదర్ ఇస్ అ ఫిజిక్స్ టీచర్. సో ఫ్రమ్ దట్ హీ గాట్ ఇంట్రెస్ట్ టు ఇన్వెంట్ దిస్ ఫిజిక్స్ లైక్ రామన్ ఎఫెక్ట్. ఓకే, he even like he became the deputy accountant general. ఓకే, తను డిప్యూటీ అకౌంటెంట్ జనరల్ అయినా కూడా తన రీసెర్చ్ వర్క్ అనేది కంటిన్యూ చేస్తూనే ఉన్నాడు. తన వర్క్ కంటిన్యూ చేస్తూ తన రీసెర్చ్ వర్క్ కూడా అలానే కంటిన్యూ చేస్తున్నాడు. సో ఇన్ 1917 తను ప్రొఫెసర్ ఆఫ్ ఫిజిక్స్లో he became professor of physics in the Calcutta University. Okay, in 1917. So these are the important points which you have to remember before going to your examination. So these points you should mention for sure. సో మీరు ఒకవేళ మీకు రామన్ ఎఫెక్ట్ మీద సమరీ రాయమని అడిగితే సో ఫస్ట్ పారాలో ఈ ఇంపార్టెంట్ పాయింట్స్ అనేవి మెన్షన్ చేయాలి. వన్ ఈస్ ఇన్ 90 when he got the Nobel Prize, where he started his education and from where he got this inspiration. Okay, and so how he became the professor of physics and at which year. So these things you have to mention. Coming like in this first para, you have to mention these important things when you come across this Raman effect summary. Okay, so without any further delay, let's go for the next para, which is B. Okay, I think you are getting the points. By the time he embarked on his first trip overseas to London as a delegate at the University Congress in 1921. So the C.V. Raman went for a meeting at the University Congress in 1921. Okay, so leading physicists of the time like J.J. Thomson and Lord Rutherford were already acquainted with Raman's significant study in the field of optics and acoustics. Okay, I think you understood what it is. So when he went for some meeting in the University Congress in 1921, they J.J. Thomson and Lord Rutherford already saw this Raman significant field which he have worked, and they know about Raman's field, his experiments and his research, and how he would be doing hard work to get anything. Okay, so you have to remember these names like J.J. Thomson, Lord Rutherford, everything. Okay, at which year they met them, and at which year what happened. So you have to remember mainly in this Raman effect unit the years and the names. Okay, will come across different years and so many names. Okay, yes, or you can note down the important names or important years in your notes so that you can remember that key points or keywords. Raman had studied classical percussion instruments like the tabla and mridangam. So not only his research and his experiments and not like his profession, he even have interest in studying in the like classical instruments which is tabla and mridangam. Okay, so more specifically the mathematical relationship that produce the pleasing effect of the sounds. Okay, I think you understood this para. సో ఈ పారాలో ఏముందంటే సో తను ఫస్ట్ ట్రిప్ లైక్ ఓవర్సీ నుంచి లండన్కి తన ఫస్ట్ ట్రిప్ వెళ్తున్నప్పుడు లైక్ టు ఫర్ ద మీటింగ్ లైక్ ఒక మీటింగ్ అని చెప్పొచ్చు యూనివర్సిటీ కాంగ్రెస్లో ఇన్ 1921లో తను ఒక యూనివర్సిటీ కాంగ్రెస్ మీటింగ్కి ఓవర్సీ నుంచి లండన్కి వెళ్ళడానికి ఒక ఫిజిషియన్స్ లైక్ జేజే థామ్సన్ కానీ రూథర్ఫోర్డ్ కానీ వాళ్ళకి ముందే తెలుసు రామన్ ఇన్వెన్షన్స్ గురించి ఎక్స్పెరిమెంట్స్ గురించి తను ఎలా హార్డ్ వర్క్ చేస్తారు ఏంటి అనేది. ఓకేనా, ఈవెన్ రామన్ ఎఫెక్ట్ నాట్ ఓన్లీ లైక్ సివి రామన్ అనే పర్సన్ నాట్ ఓన్లీ రీసెర్చ్ కానీ తన ప్రొఫెషన్స్కి కాకుండా ఈ మ్యూజిషియన్ లైక్ క్లాసికల్ ఇన్స్ట్రుమెంట్స్ని కూడా తను చాలా ఇంట్రెస్ట్తో నేర్చుకునేవాడు. లైక్ దే సెడ్ హియర్ దే మెన్షన్ two things which is tabla and mridangam. So even learned these things also like musical instruments and these classical instruments. Okay, yeah, next let's go for the next para which is C. So now let's see the third para. So it was during this particular sea voyage to London that he was struck by the blue color of the Mediterranean Sea. సో ఏంటంటే లైక్ తను ఫస్ట్ ట్రిప్ లైక్ లండన్కి వెళ్ళడం తనకి ఫస్ట్ ట్రిప్. సో అసలు మీటింగ్ వల్ల తను లండన్కి వెళ్ళడానికి తను సీ డైరెక్షన్ లైక్ సీ వేలోనే వెళ్ళాలి. సో ఆ సీ డైరెక్షన్లో వెళ్ళినప్పుడు లైక్ సీ వేలో వెళ్ళినప్పుడు హీ సా ద సీ అండ్ హీ స్ట్రక్ ఎట్ దిస్ పాయింట్ బికాస్ ఆఫ్ ద బ్లూ కలర్ ఆఫ్ ద సీ. అంటే ఆ బ్లూ కలర్ ఆఫ్ ద సీని చూసి స్ట్రక్ అయిపోయాడు. సో వాట్ హ్యావ్ డన్ లెట్స్ సీ. Till that time, it was generally accepted that the blue color of the sea was actually a reflection of the sky. సో తను ఇన్వెంట్ చేయక ముందు వరకు ఏమనుకున్నారు అందరూ అంటే లైక్ ఆ బ్లూ కలర్ ఆఫ్ ద స్కై అనేది యాక్చువల్గా దేనివల్ల అంటే ఇట్ వాజ్ రిఫ్లెక్షన్ ఆఫ్ ద స్కై. సో స్కై యొక్క రిఫ్లెక్షన్ వల్ల బ్లూ కలర్ ఆఫ్ ద స్కై లైక్ సీ అనేది బ్లూ కలర్లో కనిపిస్తుంది అని అనుకున్నారు. సో దిస్ వాజ్ కన్ఫర్మ్డ్ బై ద సెలబ్రేటెడ్ ఫిజిస్ట్ Lord Rayleigh, who has proposed that the minute minute particles in the air scattered the blue wavelength from the sun's white rays. So these lines were said by Lord Rayleigh. So what he said that the particles in the air which was there that will be scattered the blue wavelength from the sun's white rays. అంటే తను ఏం చెప్పాడంటే సో ఏదైతే పార్టికల్స్ ఎయిర్లో ఉన్నాయో అవి ఎక్కువ బ్లూ వేవ్ లెంత్ లైక్ బ్లూ వేవ్ లెంత్ని ఎక్కువ స్కాటర్ చేస్తుంది ఫ్రమ్ ద సన్స్ వైట్ రేస్. సో సన్స్ వైట్ రేస్ నుంచి బ్లూ కలర్ లైక్ బ్లూ వేవ్ లెంత్ అనేది ఎక్కువ స్కాటర్ చేస్తుంది సో దట్ మనకి ఆ రిఫ్లెక్షన్ ఆఫ్ ద స్కై అనేది బ్లూ కలర్లో కనిపిస్తుంది అని చెప్పేసి తను అన్నారు. బట్ వాట్ హ్యాపెండ్ లెట్స్ సీ. However, Raman was not convinced by his explanation. So ఈ లయన్స్ అనేవి లైక్ ఈ ఎక్స్ప్లెనేషన్ అనేది తను ఇచ్చినప్పుడు సో రామన్ వాజ్ నాట్ కన్విన్స్డ్. సో తను కన్విన్స్ అవ్వలేదు ఈ ఎక్స్ప్లెనేషన్ సంథింగ్ ఇస్ దేర్ ఇన్ సైడ్ దట్. సో హీ స్టార్టెడ్ రీసెర్చింగ్ అబౌట్ దట్. ఓకే, నౌ లెట్స్ సీ. He speculated that blue color of the sea would be caused by the scattering of the sunlight by the water molecules. సో తను ఏం చెప్పాడంటే లైక్ బ్లూ కలర్ ఆఫ్ ద స్కై అంటే స్కై అనేది బ్లూ కలర్ లో కనిపించడానికి ఇట్ వుడ్ బి ద రీజన్ లైక్ స్కాటరింగ్ ఆఫ్ ద సన్లైట్ by the water molecules. Okay, to verify this speculations he used polarized Nicolo prism. So a prism like Nicola's prism, you all know how it will be look. I'll show you the picture also so that you can get idea. So if you look at here, this is Nicolo prism. Okay, it will be looking like this. Okay, yes. సో ఆ నికోల ప్రిజం అనేది యూజ్ చేశాడు ఆన్ ద శాంపుల్ ఆఫ్ ద సీ వాటర్. సో సీ వాటర్ని ఒక శాంపుల్ లాగా తీసుకొని దాంట్లో ఈ ప్రిజం అనేది యూజ్ చేశాడు. సో టు షో దట్ light was intended scattered by the water molecules. So it is scattered from the water molecules అని ఒక చూపించడానికి he took this as some experiment like sample experiment he have done at that position. So a phenomena that he called molecular diffraction. సో వేలో లైక్ తను లండన్కి వెళ్ళే వేలో లైక్ సీని చూసి ఆ బ్లూ కలర్ ఆఫ్ ద సీ అనేది ముందు అంటే తను ఇన్వెంట్ చేయక ముందు వరకు ఏమనుకున్నారంటే ఇట్ వాజ్ ద సీ ద కలర్ ఆఫ్ ద సీ విచ్ ఇస్ బ్లూ ఈస్ నథింగ్ బట్ ఇట్స్ రిఫ్లెక్షన్ ఆఫ్ ద స్కై. సో ఆ రిఫ్లెక్షన్ ఆఫ్ ద స్కై వల్లనే సీ అనేది బ్లూ కలర్లో కనిపిస్తుందని అప్పటి వరకు నమ్మారు. బట్ ఈ రామన్ అనేవాడు లైక్ సివి రామన్ సార్ అనేవారు like our expression like our statement ki convince avale something is there inside. It's not because of the reflection of the sky. So ఆ టైంలో ఆ మూమెంట్లో సో సంథింగ్ చేయాలి లైక్ అని ఈ నికోలే ప్రిజం అనేది ఒక శాంపుల్ వాటర్ లైక్ ఆ వాటర్లో పెట్టి హీ సో వాట్ విల్ బి హ్యాపనింగ్ దేర్. సో he showed that the light was indeed scattered from the water molecules. It is scattered from the water molecules. So this is known as the molecular diffraction. So now let's see how he experimented and how it was a detailed information about this. Okay, now let's see the fourth para, which is D. So on his return to Delhi, okay, London, like sorry, on his return to India, so London ki velle darlo he was stuck with this blue color of the sea and he completed his meeting in the London. And when he is returned to his India, like his hometown and his place, so what he had done, he done research in these three areas. What is the three areas? Like the scattering of the light by liquids and the scattering of x-rays by the liquids and the viscosity of liquid. So you know what is the viscosity? It's like to measure how the liquid is like thick or it can be sticky. Okay, ఈ త్రీ ఏరియాస్ మీద తను రీసెర్చ్ చేయడం స్టార్ట్ చేశాడు అనమాట. సో యూ హ్యావ్ టు రిమెంబర్ వాట్ ఆర్ ద త్రీ ఏరియాస్. ఓకే, so on his first research like in this first area on this like he received a Nobel Prize. Okay, on these three he was worked in the first area which he received the Nobel Prize. Okay, so over next 7 years, so he along with his distinct associates such as K.R. Ramnath and K.S. Krishnan conducted and supervised many experiments along these lines. So what this Raman has said, so they have done some experiments, okay, to see it was correct or not, everything. So on the morning 28 February 1928, Raman and his associates had irrefutable proofs of the modified radiations observed in the scattering experiments due to molecular vibrations. So due to this molecular vibrations, he saw some irrefutable proofs. Okay, when doing this scattering experiments. Okay, so the discovery was announced to the Associated Press on 29th February and 8th March. So they announced in to press that about this discovery. So what they have discovered, they announced in the press. Okay, so the Raman sent a detailed note along with the explanation to Nature. It was with a sense of affirmation that he addressed the gathering at the South Indian Science Association on 16th March 1928. So what he said with the following words. So I propose to speak to you this evening on a new kind of radiation, or we can say light emission from atoms and molecules. So before this, he announced in the press about this, like he will be uh, speaking about some kinds of radiations which is emitted, like light emitted through the atoms, or it can be by the molecules. So he announced in the press before only. So by this time the experiments were replicated and the finding were confirmed, thereby leading Raman to be receiving the Nobel Prize. So Raman ki munde telsu, like he will be receiving, he was so confident that he will be receiving the Nobel Prize. Okay, so Raman has achieved what he had claimed in 1924. So 1924 already he has claimed that he will be receiving the Nobel Prize, but yes, he received the Nobel Prize in the 1930. Okay, so the meeting of the Royal Society of Fellows. Okay, in this society, like in this meeting, he have already announced that he will be receiving the Nobel Prize in the future in 1924. So he had announced that he would win the Nobel Prize in physics in the next 5 years. He already very confident that he, for his experiments, he will be receiving the Nobel Prize. That confidence should be there in every person. Okay, I think what is there in this fourth para. సో తను ఇండియాకి రీచ్ అయిన తర్వాత ఈ 3 ఏరియాస్ మీద రీసెర్చ్ చేశాడు. వన్ ఇస్ స్కాటరింగ్ ఆఫ్ ద లైట్స్ బై లిక్విడ్స్, అండ్ స్కాటరింగ్ ఆఫ్ ఎక్స్రేస్ బై లిక్విడ్స్, అండ్ విస్కాసిటీ ఆఫ్ ద లిక్విడ్స్. సో ఇదంతా రీసెర్చ్ చేసిన తర్వాత he started researching everything in this, like how the sky is blue color and how this light will be scattered, everything. And he already announced in this meeting that he will be receiving the Nobel Prize in the next 5 years. In 1924 only he announced, and he started his research in 1928. Okay, so now let's go for the fifth para, which is E para. So what essentially is the Raman effect? Asal Raman effect ante enti? Let's see. Raman discovered that when a light beam travels through a medium, it is deflected by the molecules in the medium. So ante entante, like light beam or light rays, when it will be traveling to the some medium or some, it can be like substance, it will be reflected in the molecules. Okay, it will be reflected by the molecules. అంటే ఏవైతే molecules ఆ substance లో ఉన్నాయో దానికి ఆ light beam అనేది touch, it will be reflected. Okay, so very interestingly, a small part of the emerging light beam, after being deflected by the molecules, has a different wavelength and color from the phenomena which initialized the study called Raman spectroscopy. So if you see in this figure, so this light beam is touching to this prism, which is nothing but some substance, and it will be mixing with the molecules which is there inside this prism, and it will be reflected the different wavelengths. Okay, different colors, it will be splitted into the different colors and different wavelengths. Each color will be having a different wavelengths. Yes or no? Yes. Means what the main Raman effect is nothing but, like there is another frequency rather than the incident frequency. So incident frequency కంటే ఇంకొక ఏదో frequency అనేది ఉంటుంది దాంట్లో. So that Raman has confirmed. So the mainly the blue color of this scattered will be like because of the low wavelength. So the low wavelength will be for the blue color, so that blue color can be visible easily, so that the sky like the sea is blue in color. Today, Raman spectroscopy finds a lot of applications in various areas such as study of molecular structures of components, handheld scanners for detecting drugs and explosives, and the pharmaceutical industry and medical diagnostics. So what is there in this? So the mainly the Raman effect says that, like the frequency, like the light which was passed through some medium or the medium, like medium or the substance, and the reflected light, both are same or not, like which is passed, like the light which is passed through the, I'll show the figure so that you can understand. See, the light which is passed through this medium and the reflected light which is there in this different wavelengths, these both frequencies same or not. To check this only the Raman effect was invented. So at this point, I am going to give some simple example. So ఒక ప్యూర్ వాటర్ తీసుకోండి ఒక వెజిల్లో, అండ్ డస్టెడ్ వాటర్ సమ్ డర్టీ వాటర్ అనేది ఒక వెజిల్లో తీసుకోండి. సో వెన్ యూ గివ్ సమ్ లైట్, like light beam to this pure water, we cannot see the wavelengths with our naked eye. But when you whereas the light beam, when it travels to this dust water. So dust water lo light beam అనేది ఎప్పుడైతే పాస్ అయినప్పుడు it will be mixing with this dust molecules which is there inside the water, and it will be reflected into the different wavelengths. So at this point, the incident frequency which is past this dust vessel or dust water will be not equals to the reflection of this like we can say frequency of the reflected light. Got the under, like you got the point. సో ఈ డస్ట్ వాటర్ లో ఎప్పుడైతే లైట్ బీమ్ అనేది ఇన్సిడెంట్ అయింది, లైక్ ఎప్పుడైతే ఫాల్ అయిందో అప్పుడు ఆ ఫ్రీక్వెన్సీ ఏదైతే రిఫ్లెక్ట్ అయినాక డిఫరెంట్ వేవ్ లెంగ్త్స్ అనేవి మనకు వచ్చింది కదా, ఆ ఫ్రీక్వెన్సీ రెండు అనేది మ్యాచ్ అవ్వదు. So why? Because when it will be mixing with this dust molecules, it will be reflecting into the different wavelengths. Okay, from that different wavelength, some will be having more wavelength and some will be having the less wavelength. Same phenomena here. So which is having the less from that colors, like we will be seeing more colors, like we'll be seeing this rainbow colors. From these rainbow colors, blue color will be having the less wavelength, so that the sea is in the blue color. Okay, now you got the idea how the sea is blue color and what is the Raman effect. I think you understood this Raman effect, and I'm giving you the small exercise. This is the exercise. Yes, choose the sentence that best summarizes the main idea in the each para of the text. I have explained each para detailed and clear manner. So once again, see each and every para and try to identify which is the correct option from these three lines and from these three sentences, and pin me in the comment section. So I will be definitely see your answers and try to solve, like try to complete these exercises to check your understanding. Okay. One more thing, I want to give you one more exercise. I will be sharing you one form below this video, so that you can read the question and answer your specific thing and share me, so that I can see your all answers. So please complete that exercise also, so that you can understand at which point you are. Okay, and at which level you understood this unit. Okay, that's it for this video. Thanks for watching. Let's meet in the next video.